So this is the violation of the random assignment. So yeah, I already explained why the most of case is not randomly assigned, because we just collected the information afterward. So our data is really hard to find out what is the effect of the program. So let's say W is a treatment. So it's a 0 or 1. W is a 0 or 1. Right? And then I want the effect of this treatment or the policy. I want to find out what is the tau. If this is the effect of our program. However, as I told you, it's not randomly assigned. So what we can do is we can just simply assume this is a randomly distributed, and then you just use this number. Okay, this is like a negative 0.052 is the effect, but that's not correct answer. So can we do the better? Yeah, we can do a little better, but still, yeah, we cannot make it perfect. But can we do a little better? So how can we do a little better is using these other factors. Since we can find out the all other factors, if you taking out the all other factors out, then maybe we can have a purely the effect of our program, right? So this is this slide is the why this is the problem. Why is not randomly assigned is the problem. Then how can we overcome? So idea is we will take it out all the x1, x2, x3 effect, and then we can take it out this one. But still, if you just do the regression itself, you cannot have a right number. Again, if we use some other things, still you cannot have the correct answer, but we can do the little better using the other independent variable. So we will use these things again. I think I will do it a little later. So this is a y equals 1 minus w times y0. I think why they use it. So when w is a 1, if w is a 1, this will be 0 and this will be just y1. And w is 0, then this is a 0, then this will be 0. So you will have just y0, right? So you can have a y1. If you create the y equals this way, you can have a y1 when w is 1, and you can have a y0 when w is 0. So I can change this one a little bit differently. It's a y0 plus w times y1 minus y0. Right? Basically, this is a same equation. So using this one, we will create another regression model, and so that we want to find out what is the effect of the W, which is the treatment. So here this one is the expected of y when the W and x is given. So we will have two different model here. So we will separate out y0 and y1. So consider the simple regression is this one. So we will, if we just take it out the effect of the W, then we will need a strong assumption that W is independent of the y0 and y1. But however, the treatment is not randomly assigned. If it's randomly assigned, then you can just do the simple regression and you can find what is tau, and then we can tell what is the effect of the program easily. However, since this is not the randomly assigned, we have to include this covariate. Why we call this covariate is I'm not interested of the effect of this x1, x2, x3, x4. This is what I'm interested in. However, to take it out this problem, because our data is treatment is not randomly assigned, so we're trying to get more accurate result. So using this x1, x2, x3, x4. So I'm not interested in the x1, x2, x3, x4, but I'm using it because I want to get a more accurate effect of our program. So this is what we call the covariate. This is what we covariate, which is I'm not interested in. And created a Y model. And then we will use this one, and then we will do the regression and then find out the effect. This is what we call the regression adjustments. How can we adjust our regression? So, as a result, ATE is the average treatment effect. That's, in short, this ATE will be tau here when we do the regression using this form, this model, alpha plus tau plus times wi, and the gamma 1, xi1, gamma k, and then this is a delta 1 wi times xi1 minus x bar 1, and so on. This is kind of complicated, but if we use this model and then run the regression and then find this tau, then this tau will be the average treatment effect. So this is the effect on our program. Now, even though my data is not, treatment is not randomly assigned, we taking out the all other effects so that we just trying to get out the pure effect of our program. Again, this is not perfect, but this will be the better than just do the simple regression against just W. Okay. So regression that allows the individual treatment effect to vary is known the unrestricted regression adjustment, and then restricted adjustment force the treatment effect to be identical across the individual. So everybody has the same effect. However, we can divide two different ways. So I will talk about it a little more about how this will work. But usually we don't use it, but